going to show you how you can do nonlinear equations using Newton Raphson method in MatLab. Okay, let me open the MatLab. So yeah, this is the equation that we are going to solve, and this is the Newton Raphson expression you can see. So this is basically, I don't know if you can see, yeah, you can see that this is the differentiation, like the f dash x and that at x naught. Anyways, let's just do Newton Raphson. I'm gonna create a file and call it Newton Rap. Oh shit, I already have one. Okay, I'm just gonna delete that. Cool, I don't have any more. Okay, so enter, resize this window. Okay, so very first I need what I need is a function. So I'm gonna define the function using anonymous operator. My function is x squared minus 5 times x plus 6. This is my simple equation. Okay, what else do we need? Well, I'm gonna need x naught, which is initial guess. Let's just say my x naught is gonna be maybe 5. We're gonna change that, don't worry. Okay, other than that, what I'm gonna need, maybe I'm gonna have to run a loop from maybe 10 times. I'm gonna run this loop. So this loop will basically calculate x value using Newton Raphson equation each time, and each time it calculates x value, for the next run we will store that x in x naught, so that for the next case x naught changes. So yeah, basically we have to keep updated our x naught value. So x from Newton's Raphson method is f of x over, okay, so this is where we need to write differentiation of fx. What I'm going to do is I'm going to store differentiation of fx in some variable and then use that here. So let's just say I store that variable in g, differentiation of fx. Okay, so I know that the differentiation of fx for my case is going to be 2x minus 5, right? And 2x minus 5 basically has x as a symbol. So in order to store that in g, I need to tell MATLAB that there is a symbol called that looks like x. Okay, so now I can store that expression in g, and okay, so here I'm gonna have to calculate g of x naught. Okay, also here. So yeah, I cannot calculate g of x naught just by having an expression of g. I have to convert that expression in inline expression. So MATLAB basically, like, let me show you, maybe you haven't seen that video, but so if let's just say I have f x square, this is my function, yeah, this is my basic function. It does not recognize x, since x, come on. Okay, now this is my, yeah, so now MATLAB knows that f is basically x square. But what if I ask my MATLAB what is f of 2? See, MATLAB does not know what is f of 2. So if I want to calculate f of 2, I'm gonna have to tell MATLAB that this is my function, it's just not a symbol. Okay, so that I can do by telling MATLAB, hey, make my function f inline function. Okay, now my f is an inline function, and now I can calculate f of whatever I want. I want to calculate maybe f of 1000. See, it knows how to do that. So that's why I'm gonna have to do, like, I cannot just calculate g x naught. I'm gonna have to convert that g in inline function. So how I can do that? Let's just store that g inline function of g here. I'm gonna have to write inline g, that's it. Okay, also I have to change this because now my inline function is I. Okay, perfect. And what we need to do, we need to update x naught. So yeah, every time x calculated, for the next time x calculated right now becomes x naught. Okay, and this loop, and display me the answer, which is basically x. Okay, let me see. Okay, it worked. So what we have is 3. Okay, let me just suppress the output. I don't like this. Suppress output, run again. Perfect. What we have is 3. So I know that this is a quadratic, it has 2 roots, and MATLAB gives me only 1. So MATLAB basically tries to find out the root which is near to your initial guess. Let me change that initial guess and let's see what we have. Maybe 10. Let's see if we have another root. No, it's still 3. Let me change that to maybe 28. Again 3. Okay, I'll go on negative side, maybe -5. Let's see what we have. Okay, so our next second root is 2. So the two roots of this quadratic expression are 3 and 2. That's it. So that's how you get to yeah. Keep in mind that MATLAB basically tries to find out the root which is near to your given initial guess. That's it. Okay, so this was very simple. Like, the next code that I'm gonna show you is how you can write like Newton Raphson method, which will take basically input from the user, an equation, and also the initial guess from the user, and how you can handle that. That's what I'm gonna show you. Let me create another file. I'm gonna call that Newton. Okay, I'm gonna call that Newton interesting. Yep, I don't have that file. Create it. Okay, so very first I'm gonna need an equation. So I'm gonna have to take input from the user. Please enter function and then receive that function. Okay, so we know that MATLAB input command basically expects the user to give us number input, right? So in order to handle input that contains some symbols, you need to tell MATLAB that you are expecting basically the expression that includes these symbols. Okay, that's how we do that. And then this f basically is combination of symbols, but you need to turn that in a function so that you can calculate maybe f of something like f of x naught. So to do that you need either inline function or an anonymous operator. Let's just do inline function. I don't think anonymous will work, we'll see. So my f, I'm gonna change that and make it inline so that I can calculate f of x naught. Okay, and what else? I need initial guess. I'm gonna take that from user. Let's just see. What's your initial guess? Or maybe initial guess. Just keep it simple. Initial guess, please. Okay, so this is basically it expects the user to enter some number, and that's what input command basically handles. So we don't need to symbolize anything. What else do we have? We can just write for loop maybe, running from 1 to whatever number of times we want. Let's just run 10 times. Mostly it's enough. Okay, and then the expression, I'm just gonna copy paste that expression. It's not gonna change obviously. Okay, great. We have our function, we symbolize it, we turn it into inline function so that we can calculate f of x naught. And so we know x naught, we know f of x naught, we can calculate that. Okay, I x naught, we cannot do that yet. So I x naught has to be, first let me just store in G the differentiation of f of x, and then store in I inline function of G. Okay, so this will let me calculate I at any x value. Let's see what we have. Enter the function. Okay, I'm gonna enter, first let me check x square minus 5 times x. plus 6, the last. Okay, that's my function. I should have suppressed the output. Okay, initial guess. Let me enter 8. Okay, that does not seem. Oh shit. I did not print the answer, that's why I did not print answer. Anyways, I know my answer is x and x value is 3. That means, yeah, voila, we got the answer. Let me display my answer, which is x. Let me make it more interesting. What we can do? Okay, is that how we do that? I guess so. Let's see. Here is the answer. And then num to string. Come on. Num to string what? I wanna convert that. X. Shit, I should have again. Okay, I'm gonna suppress this output. I don't need that to see. Everything else good. Okay, also clear this and run. So enter function. X, maybe this time I'm gonna write x square, maybe 2x square minus 5 times, not 5, let's just say 5 times, sorry, 8 times x plus 2 maybe. Okay, shit, that was incorrect. Okay, 2 times x square and then minus 8x plus 2. Good. Initial guess I'm gonna give 3. We have error here. So the problem is with this. Okay, so this is how display commands should be written. The square brackets just besides the parenthesis, and yeah, everything else between those square brackets. Anyways, let's just run that command. Clear everything first. Go here, run it, and write my equation that I want to enter is 2x squared minus 8x plus 2. Yep. Initial guess is, let's just say 4, and here is the answer. It's 3.7321. Perfect, we have the answer. Okay, this time, because answer in 3 does not have a space, I'm just gonna increase a little bit of space. Okay, and this time I'm gonna give it different equation. Maybe 7 times x squared plus 4x minus 9. Oh shit, not control S. Enter initial guess, I'm gonna give 8, and here is the answer, 0.88362. Perfect. So yeah, this is how basically you can do Newton Raphson method.